I want to start off today talking about that question, okay? Does side-side angle guarantee congruent triangles? We've introduced side-side-side. We've talked about side angle side. Yesterday, we worked through angle, angle, angle. I gave you that visual that angle, angle, angle does not guarantee congruency. Angle, angle, angle can have congruency, but it does not guarantee it because you can make the distance between your three angles essentially anything you want to, okay? So it creates basically a dilation of the triangle we started with. Now the question is, does side-side angle guarantee congruent triangles? And the reason I think it's important to do this stuff, guys, is because I don't want to just give you information that says this will always work and not give you explanations of why the things that don't work, okay? Or maybe don't always work, okay? So that might shed a little bit of an answer on this statement here, or this question. But I want to show you, if I start with side-side angle, okay, what happens throughout this process. So just like before, just like the other ones that I've created for us, let's see if we, 0.05. If we start sliding that thing through, okay, so I'm going to take that angle, and I'm going to just cut and paste it so it has congruent angles. Is that all right? Okay. You guys agree that those two angles are both 45 degrees? Yeah. Okay. I'm going to then take that side and paste that there. Is that all right? So you agree that I have side and an angle so far. Okay. Now, it might be a little bit more, I wrote it as side-side angle, but we know these things are reversible. Probably shouldn't write this, okay? But angle side-side, right? That's what we're looking at, okay? So I started with the angle. I now have a side, and then I'm going to go and pick off the other side, the red one, okay? Would you guys agree that those set of red ones are still congruent? Okay? Now, once I've put in this blue one here, okay, I put in this little, we call it a vector, but I put that in there to show you that that has to be kind of where that third segment of this triangle is going to be passing through, right? Because if I put maybe, because I'm using angle side-side or side-side angle, this point C prime can float, okay? Because I'm not forcing anything on this angle here compared to that one. Does that make sense? Okay, so it can float. But it's got to come up. I can't put it there because when I make the third segment, you see how that kind of cuts into the angle when I make the triangle? Okay, it cuts into that 45-degree angle, which we know we can't have because that would then change the fact that we have congruent angles. So what happens is that we have to actually extend this third side here that we know is being defined by the edge of that angle or the side of that angle. And now I need to move this point C prime so that it intersects there with that third side. Does that create a triangle? What do you think about that triangle compared to the first one? Congruent, absolutely, 100%. Okay? So there's a situation that side-side angle or angle side-side gave us congruency, right? All right, I'm going to start over. With maybe something like this. Okay? Congruent angle, right? Congruent side. Okay, so blue sides are congruent. Red sides are congruent, right? Both 8.98. Okay? But now if I show that extension, and I intersect C prime with that extension, with that third side, are those two triangles congruent? No, but the parts are, right? The blue segments are the same length, the red segments are the same length, and the angles there in the bottom left are the same. But it doesn't guarantee a congruent triangle. Does that make sense? Okay. However, what makes me think that that's the only place C prime could have been? Can't I swing this that way? And now intersect that segment that way? Does that make sense? What's that tell you about those two triangles? Those are congruent. All right, so here's the thing. What we have right here, we'll call it angle side side. We call it the ambiguous case. Okay? I guess know what ambiguous means or ambiguity? Let's say I have a parent, and their name's Pat. You know what I'm talking about, my mom and my dad? You don't know, right? Okay. It's open to interpretation, correct? I have to give you more information for you to make a distinction that it's to my mom or my dad, right? Does that make sense to everybody? Okay. So when I say something is ambiguous, you can interpret it multiple ways. You know, the same thing if I say everybody look at the angle at C prime right now. Are there a couple angles at C prime? All right, so be ambiguous on which one I'm talking about, okay? Kind of fuzzy, does that kind of make sense? Okay, vague, maybe a way of thinking about it. So this is the ambiguous case because when I have those parts, those congruencies of angle side to side, the parts do not guarantee one triangle to be created that is always congruent to the one I started with. Does that make sense? We might get congruency. Here we get congruency with this one. But who's to say I might have rearranged my parts on my desk? We go through that activity we've talked about in that manner. And now we see that even using the same exact parts, now I don't get congruent triangles, right? Okay. So we don't allow angle side side to be one of our theorems or postulates because it doesn't absolutely 100% of the time give me the exact same triangle. Okay. Is that all right with everybody? Now, we will talk about that case a little bit more eventually. Okay, we'll talk about what we call law of sines and law of cosines. We'll start getting really into this triangle stuff, and we'll come back to this and address it. The reason this all happens, you know, the first case I gave you, there was only one triangle to create, right? Okay, if I go back to this triangle here, there's only one triangle to create here because if I swing that there, that goes right on top, right? Does that make sense? Okay. And to make it even more kind of obvious, if I make triangles like this, there's one triangle of congruency. Come over here and swing again. Do I even hit that third side to create a third point of intersection over here? Does that make sense? Okay. That idea. So this one, with that information based on the size of angle A here, there is only one congruent triangle that I can make because I can't make a second one. So the size of that angle right there all dictates whether you have one triangle that is congruent, the one you started with, or you have two triangles, one of which is congruent and one of them which is different. Okay? So because of that situation, we don't allow angle side side to be a theorem of congruency. It doesn't always guarantee a one-to-one congruence. Does that make sense? All right. I think it's very important, guys. It's the approach that I take a lot with all my classes: geometry, algebra, trigonometry, to learn something the way it is, but also learn, you know, why something doesn't work. Okay. If I can learn why it doesn't work or why a feature doesn't exist in a particular case, it helps reinforce the direct approach and the way that it does work and the way that we do apply it. Does that make sense to everybody? So seeing why angle side side doesn't work maybe helps me understand why side 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 does and why side angle side does, okay, and why they always guarantee congruence. All right. So today what I want to do is, now we know that, okay, I want to go on with a couple proofs. I think we're going to do two proofs here today. And we'll start off with this one. This one's very similar to what we did yesterday, okay? Very similar picture. If you kind of judge off of the proofs we did yesterday, you can look and see which one this is like. But I'm starting off with different criteria, different given information. So it should change the course we take a little bit. So give me a minute to write that down. I want to kind of guide you a little bit with the word perpendicular up there. Okay, we see that symbol upside down capital T, right? It means perpendicular. So we haven't seen that a whole lot, maybe a couple times inside of a few proofs. But I want to guide you on the two steps that usually go together when we deal with that vocabulary word. All right, the reason I want to guide you with this is earlier I asked this last class, and I said, go ahead and take the given, write down everything you know from the given, write down your 2 statements, 3 statements that come from that, and then look at your picture and come from that. So I told them out on their own, kind of develop the bulk of this proof, okay? And right away, somebody said, well, I see that I have perpendicular segments, right? And they instantly said that that means that we have 90-degree angles. And then my argument to them is, okay, then what do you write as your reason? Okay, why do you know that, angle DBA? Okay, so I'm going to write these out, angle DBA. And angle DBC. And now don't write this part, but they basically told me both those equal 90 degrees. Okay? I said, okay, well, what's your reason? And she said, definition of perpendicular line. So I said, okay, flip back to the back of the book. Flip back to your notes where we have defined perpendicular and read it to me. And if you do that, it's going to read that there are 2 segments that intersect and form right angles. Does the number 90 ever show up? Okay? 90 is never in the definition, right? Does that make sense to everybody? Okay? So my reason that I can go from DBA to DBC equaling 90 is actually 2 things. It's the fact that I have the definition of perpendicular lines, and I know what a right angle is. I know that definition. Is that all right? So we can't do that. We can't make this jump right away. So I'm going to go angle DBA and DBC based off of being perpendicular are right angles. Okay, because that's explicitly what the definition of perpendicular lines gives us. All right. And now the next thing I would say is angle DBA. If DBA and DBC are both right angles, what can you say about them together compared to one another? They can grow. Okay. Now you could make the argument that, well, DBA and DBC are right angles, meaning then that measure of angle DBA equals 90, measure of angle DBC equals 90, and if they both equal 90, then they're both equal to each other, and if they're both equal to each other, then they're congruent. And that's about 4 or 5 extra steps, okay, which essentially those 4 or 5 extra steps are the proof of the theorem, one of the first theorems we came up with that said all right angles are congruent. If I look at the word perpendicular and I come up with the word perpendicular in my proofs, okay, I don't want to say every single time, but I say maybe 90% of the time, those are the types of steps that are going to follow that vocabulary word. Okay? You don't have to start talking usually about the 90-degree aspect. Okay? Because the reason we start talking about 90 degrees is that I can make it equate to another 90 degrees, which then will allow me to equate 2 angles measurements or make 2 angles congruent, which is ultimately what we get here by using that theorem. Okay? Does that make sense? All right, so kind of keep that, structure that in your mind that when you see perpendicular, those are the types of things that I want to write off of that. Okay? Now I want to draw out my picture. All right, so now I want you guys, if you want to, I guess you could put the symbols, the right angle symbols in there. Now I want you guys to go through the next vocabulary word and write down what you get from the next vocabulary word. Do that on your own. Once you get that done, maybe you can look at your picture and find out what you get from your picture. So if B is a midpoint of AC, did you guys write down that AB should be congruent to BC? Again, every time that we see a midpoint, it gives us the same exact information every time, right? Now, it might be different letters that we use, that kind of stuff, but it's going to give me two segments that are congruent, okay? So now I know in my picture that, right? What else do you know? What's in your picture? What is the next piece of information that you can get from your picture? What's the plan? What's the process? Always go vocabulary and our given, exhaust all that, then look at our picture, and there are three things we can look at our picture. Linear pairs, vertical angles, and common segments, right? And there should be kind of a hierarchy that you look for common segments first, then vertical angles, then linear pairs. So what do we have here? What can I say that's going to allow us to come up with another congruency? Thank you. DB is congruent to DB. And that's the reflexive property, right? All right, so here's the thing. As we go, so we got three congruencies so far, and we should then eventually be able to say these triangles are congruent, and we'll talk about that in a moment. But those statements, guys, can all kind of float around wherever they want to in the beginning of this proof, okay? These two that I've got the, let me just maybe highlight these real quick. These two have to come in that order. And they have to come after I've said perpendicular. DB and AC are perpendicular. Okay? But they can come anywhere after DB perpendicular to AC in that order. So those two could actually be statements 3 and 4. They can be statements 4 and 5. Does that make sense? Okay? The only thing that those statements depend on is this one that my cursor's on. Okay, so as long as they come after my cursor, okay, we're good to go with those. Okay, now this one here is dependent of this one. Does that make sense? So this one I cannot say that the angles are congruent before I said that both of them are right angles. Because right angles is what allowed me to say that they're congruent, right? Okay, so that means that that one has to come after that one. But this one here, okay, that does not impact it or does not rely on either of these green ones, does it? This one here just relies on the midpoint definition, correct? So what if I could put that second if I want to, okay? And then put, you know, these things, don't mess everything up, but I can put those things down there and put that second, okay? Because this only depends on the midpoint, which is just come after that. The same thing with let's kind of fix that. The same thing with these two things, okay? 4 and 5 could be flipped because DB, DB, nothing impacts that. That could actually be before my given if I want to. Does that make sense? Okay, that green statement can DB or DB can go anywhere before statement number 1. It could be number 1, it could be 2, 3, 4, 5, whatever. Okay, they're independent. They're not impacting one another. Is that all right, everybody? All right, that's a very important thing to understand. If you have you've got overall structure of the proof, but within the proof, you've got a little bit of freedom to kind of jockey around some of the steps if you want to. If I look at my picture, this is going to be kind of what your homework is going to involve today. I'm going to give you a handful of pictures that have markings in them. I'm going to ask you, are these two triangles congruent? And if they are, tell me why. This is the process that you go through. You cover up one of them. You say, okay, and the one on the right, what is the order of parts that I have? Side angle side. You would then uncover the one on the left and cover up the other one. And I'm going to ask you, what are the order of parts that you have there? side angle side. Okay? So then when I uncover both of them, do I have side angle side in both of them? Yes. So because that statement side angle side is consistent in both triangles, you do have congruence. Okay? If one of them was side angle side and the other one was side side side, you do not have congruence. If one was side angle side and the other one was angle side angle, you don't have congruence. Okay? And that actually happens a lot. You'll see a little bit of that in your homework tonight. But I do have congruence. Okay? So now I can say triangle, whatever you want to call it, congruent triangle, essentially whatever we want to call it once we name the circle. What do we want to name the first one? Let's talk about this one on the left. What do we want to call it? ABD? Okay. So then over here, if I started at A, what letter you going to start over at on this one? C. I start at C. Okay. Because A was the angle created by the sides that have one mark and no marks. So then over here in this triangle, you got to find the angle created by the sides that have one mark and no mark. Let me see. Then you went to B, so you travel from A, you travel down those segments that has one mark in it, right? So if I start at C, I got to do the same process. I go down to B. And that will let me finish at B. My reason? Side, angle, side. Whenever we write triangle congruence, the reason, whenever you say two triangles are congruent to one another, the reason will always be three letters, and if they're right triangles, we'll get to that later on. Use two letters, but it's always going to be a very short theorem here. Okay, is that what I wanted to prove? No. But once I have that, look at AD. A being the first letter here, the last letter there. What are the first letter here and the last letter over here? AD and CD. Are they corresponding then? Yes. Now I can say AD is indeed congruent to CD. A reason? Corresponding parts of what? Where does the corresponding parts come from? Congruent triangles. The corresponding parts of congruent triangles are what? Congruent. We said they're congruent, right? So AD and CD are corresponding parts. They came from congruent triangles. We are saying that they are indeed congruent to one another. That's what that CCCCC stands for. All right, so that's very similar to what we did yesterday. One of the questions yesterday, but I started you off with different information. Essentially today, I started you off with a set of angles congruent. I guess not angles congruent. I started you off with perpendicular lines, which led you to angles congruent. Yesterday, I just started off with giving you two explicit congruencies with the, I think I used like AD and DC to be congruent, and then I still used the midpoint to show you the other congruency. Okay, and we proved these two triangles to be congruent yesterday by side, side, side. Okay, provided different information, we can prove them congruent by side angle side. I want to do one more. A little bit more difficult. The other one, I found the other ones today. They're back there somewhere. My blue one is, I think, on my washing machine. I just put them in my pocket. You should see how many expo markers I have at home. I just put them in my pockets and I walk out. Not on purpose. I don't have empty pockets for 315 and just start stashing things in my pocket. I'm not like, I'll do anything like that. Like today, I put them in my back pocket. It's there. Huh? don't wear it. You don't like. I guess girls probably don't wear wallets, but carry wallets. You can wear pants. Yeah, you carry them in your purse. All right, so this one, guys, this is a situation where if you abide by what I've stated yesterday and maybe the day before, when we're trying to show triangles congruent, we need three congruencies to exist on the left-hand side in our statement. What's going to happen here is that we're going to start off with two congruencies, AB congruent to AC and angle 1 congruent to angle 2, but those are not, both of them are not part of the three that we need. Because look at angle 1 and angle 2. Are they parts of your triangle? No. Okay. Angle 1, I'm going to color them. But angle 1 is this exterior angle. Okay. Angle 2 is the same thing, but on the bottom. Okay. So that's what we're looking at as being congruent there. We also have AC and AB being congruent. So that segment there and that segment there being congruent. Don't write that stuff down. That's a given. AB congruent to AC. Angle 1 congruent to angle 2. So what I want you guys to understand is when I said yesterday or the day before that when we're doing these triangle proofs, when we have three congruencies written on the left-hand side, we're done with showing our information. I'm really saying that with the understanding that those three things are parts of your triangle. Does that make sense? Okay, so you might have 4 congruencies, you might have 5 congruencies over there, but we're looking for 3 that are part of our triangle. So right now, that is the only one that we have. So we need to go through and find 2 other congruencies. All right. Now I don't care how they're going. I'm not going to try to force myself to say they got to be all sides. My next 2 congruencies got to be 2 sets of sides congruent, or 1 angle on one side, or both angles. Okay. I'm just seeing what they present me with. Okay. What's the picture telling me? If I look at that, essentially looking at this picture with, I think the last class was struggling with kind of this extension over here. So let's just kind of wipe that away real quick. Look at those 2 triangles. That's what we're trying to prove congruent, right? This was point A. What segment do they both share? AD, right? Can I say AD is congruent to AD? Reflexive property? Oh, yeah. Is that all right, everyone? Okay. So now we've got 2 parts in the top triangle. Here's 2 parts in the bottom triangle. That's awesome. Straight. And the 3rd one. Okay. So what would be really convenient and really nice, and I think I'm trying to recognize why we can't do this, will help us later on in other proofs. Wouldn't it be really nice to show those 2 segments congruent somehow, and then I have side, side, side? Does that make sense to everybody? Okay. So I want you guys to know, you might want to write this down, the only ways right now that we have to show segments congruent is through the use of a midpoint or some other definition or vocabulary words that incorporates midpoints, like perpendicular bisector or segment bisector, because they incorporate midpoints at some point, don't they? That's the only way right now we can talk about congruent segments. Or if we use the segment addition postulate, but if you use the segment addition postulate, those 2 segments would have to be comprised of 3 points that are collinear, and they're not. Okay? So the segment addition postulate does not work. So what I'm trying to say is that if your goal is to show segments congruent, that's a very hard thing to do right now. Okay? We don't have a lot of stuff that says, other than midpoints and the segment addition postulate, that that's going to happen. But we do have a lot of things, a lot of relationships that we can say about angles and show angles congruent, right? And another thing that might help you is just kind of a notation thing or a procedural thing to understand. The author put angle 3 and angle 4 in my problem, right? Have we used those yet? No. They didn't put those in there just because they wanted to be cute and fancy. They put them in there to help you. Draw your attention to that stuff. We want to talk about angle 3 and angle 4. Okay? If I'm able to show angle 3 and angle 4 congruent, what does that tell me about those two triangles? What relationship do we have in them? By what theorem or postulate? What would be the order of parts that you have? You have a segment followed by an included angle by then a segment. We have SAS, if we were able to show those angles congruent. Okay. So that's the route we're going to go. But now we got to figure out how we can do this. Okay. We don't know if we can't just arbitrarily say angle 3 is congruent to angle 4 because we want it to be. You have to have proof that they are. Okay. So we haven't targeted that information yet either, so that's probably going to be incorporated. That's part of the reason why 3 and 4, part of the reason why 3 and 4 is congruent. What do you know about 1 and 3? What kind of angles are 1 and 3 together in the group? Okay, they're supplementary. Don't they form a linear pair? Okay, so let's write the angle 1 and angle 3 are supplementary. We talked about that being a linear pair postulate. You can visually see that two angles make a linear pair. You automatically know they're supplementary by the linear pair postulate. What can I say about 2 and 4? 2 and 4 are also supplementary. Okay. Same radius, so I'm going to put that all in there, number 3. All right, so now we've got two options. We can use the theorem, or we can do about 4 or 5 steps of algebra. Okay. I want to use the theorem. I want to show you the benefit of a theorem, because we're going to decide then, and I'll work through the algebra to show you why we're trying to learn these theorems. Okay. If I've got a tool that allows me to say 5 or 6 things within one statement, I'm going to use that tool. Okay. But here's the idea. We talked about this a while ago. It was over a week ago we mentioned this theorem, and this will be the first time that we've used it. Because angles 1 and 3 are supplementary. Angles 2 and 4 are supplementary. What was the relationship that you knew about those two things previously in the proof? Angle 1 and angle 2 were what? Congruent. Okay. So angle 1 and angle 2 are congruent. Kind of do this with me. Let's put a number in for angle 1. What do you want angle 1's number to be, or its degree? 72. Okay. So if that's 72, that's going to be 72, right? If those are 72, doesn't that one have to be 108? And that one be 108? Okay. So does that show you numerically that 3 and 4 have to be the same angle? That'd be congruent angles? Okay. So this theorem gets at that concept. Okay. We have angle 1 and angle 2 are congruent. Okay. 1 is supplementary to 3. 2 is supplementary to 4. What we gain from that is that angle 3 is congruent to angle 4. Okay. I'm going to type in. It's a long statement. I don't want to. My handwriting's kind of messy with that thing, but see here. The name of the theorem was called the congruent supplement theorem, which stated if two angles, in this case we're talking about 3 and 4, are supplementary. Well, that's stupid. Hold on. There we go. are supplementary to the same angle or congruent angles. In this case, 1 and 2. Would you guys agree that 1 and 2 were congruent? Then the two angles, in our case, 3 and 4, are congruent. Now, that's a lot, okay? Now, I put in the specifics for our problem. I want you guys to realize and see what we're talking about when I say two angles are supplementary to the same angle, congruent angles, and the two angles are congruent. I want you to be able to reference, well, what were the two angles, what was the same angle, what was the congruent angles, that kind of thing, okay? So if two angles are supplementary to the same angle, so these are your two angles, 3 and 4, are they supplementary to the same angle or congruent angle? They are supplementary to congruent angles, right? We said 1 and 2 were congruent, okay? Then the two angles that we started with, 3 and 4, have to be congruent to one another, okay? That's what the congruent supplements theorem says. What is nice about using theorems? Here in a moment, we're going to see that that's about, I think it's 4 or 5 lines worth of work to get to that statement if I don't know that theorem, okay? To determine angle 3 and angle 4 congruent, without that theorem, it's kind of a process. But now that we've got angle 3 and angle 4 congruent, let me clean my picture up a little bit here. Can we say that, so this was 3, that was 4, they're congruent. We had this side up here, and this side down here is congruent. And we also said AD was congruent to AD. If I look at just the top triangle, or cover up the top triangle, what is the order of parts that you have in the bottom? In a side, an included angle, and a side, right? You have SAS, that's your SAS in the bottom. If I cover up the bottom, and look at the top now, do I have SAS in the top? All right, so these two triangles now are congruent. Say triangle, picture back, triangle ACD. It's an option, name that top one. It's called ACD. I should probably call the bottom one ABD. They're congruent. And my reason now is that argument that we saw the parts in the order of side angle side one. Then we just got to make sure that matches up with what we want to prove. If it doesn't, we're going to prove B congruent to C, right? C is the middle letter. Is B your middle letter? All right, so that's it. Angle C congruent to angle B. CP. Corresponding parts congruent triangles are congruent. Turns out to be a nice kind of property or theorem to talk about once we start talking about rhombuses. Okay, when we get to that section of text for kites. Okay, if you know what a kite is. All right, so here is my question. Can we do this a different way? If I forgot my congruent supplement theorem, can I approach this differently? And we should be able to. So let me kind of pull that to the side and let me get the blank screen up here real quick. So this statement here that angle 3 is congruent to angle 4 is because of the congruent supplement theorem. We'll put a box around that. I'm going to come over here to the side, and we're going to do similar work. Okay? But looking at our picture, so I'm going to say, if we look at our picture, I know it's kind of small here, but 1 and 3 which we said in this statement right here, were supplementary, right? Well, if they're supplementary, doesn't that mean measure of angle 1 plus measure of angle 3 equals 180? By the definition of supplementary angles? If that's the case about 1 and 3, what can I say about 2 and 4? Same thing? Okay. Do you guys remember seeing statements like this when those two things were equal? What's that tell you about these two things? They're equal as well, right? All right, and that was substitution. Remember back doing those types of proofs. Okay, so those earlier proofs that we did, some of the algebra that was incorporated in those, is going to be used in the new proof. All right, and sometimes we work around that algebra by using the theorems that we learned in sections 1, 2, or chapters 1, 2, and 3 that kind of encapsulate this algebra. What is on both sides here that we know to be the same amount? Do we know 1 and 2 are congruent? If 1 and 2 are congruent, can't I remove 1 from the left? Remove 2 from the right? I get subtraction, right? If I got angle 3 is equal to angle 4, doesn't that mean angle 3 is congruent to angle 4? And those 4 steps, guys, are the proof then. Everything's messy here, but that's the proof of the congruent supplement theorem. Okay? Would you rather write a proof? Here's my final argument. Would you rather write a proof that is 10 steps long or a proof that is 6 steps long? 6 steps, okay? The benefit is less writing, right? Okay? But the cost of that is that we have to learn our theorems. We have to know our theorems, and we have to be able, no matter how vague they are, and how infrequent we use them, they have to be tools at our disposal if we want to write concise arguments that have 6 steps instead of 10 steps. Well, I want you guys to do for homework tonight. Should not take very long. Okay? If it takes you more than 5 minutes, I would say there's a disconnect between you and the information. Okay? Under section 4.2 on my website. Okay? You see this purple link right here. Okay? Click on that. And then you go up to download. Click on that. It'll download to the bottom here. Sorry, it's not the purple link. Purple link was today's notes. It's this link. I apologize. The bottom link, the one that says additional homework. Click on that. Click on download. It'll probably download or it might just open up. But this is your homework assignment. Okay? What they're asking you to do is exactly what I was doing or what we were doing inside our proof by covering up one of the triangles. And saying, okay, what is the order of parts that I have here? I have side, angle, side, or I have side, side, side. Then cover up the other triangle and keep getting the same thing. Does that make sense? Okay? Now, you might be able to, in some of those, like look at number 6 up there. Okay? They don't mark KO, but you know that there should be KOs in both triangles, right? So you can put in marks in KO so that you do have side, side, side there. Is that all right with everybody? So there might be hidden information based off the way we look at our pictures. Have that done. You don't have to print that out. Just do it on a piece of notebook paper or whatever. And we'll talk about that tomorrow.